And looks like the sound works good. Hello, everybody again. Just wanted to give everybody a heads up. Today we're going to do, well, this video is going to be our answer key and the questions for our first homework, just to explain everything in case you got anything incorrect. So we'll start with this here. And let me get the answer key out as well. And so let me share this with everybody. And here we go. So our homework was as it sees this here. Now, first one was I wanted to see if you could identify types of astigmatism, compound myopic, simple myopic, compound myopic, simple hyperopic, compound hyperopic, or mixed, the orientation, and essentially what would potentially be the best GP for this patient. And remember, there's a little cheat sheet here. If the corneal toricity is over 2.5, it's bitoric. And if the RxSil is about a quarter to a third higher than the delta K, then the answer should be back surface toric for tests and quizzes and stuff like that. If you just give me bitoric, I'll be happy. If you order a bitoric from the lab and it happens to come out that the front surface happens to be perfectly spherical, nice, great. But for my purposes, it's immaterial. But I do want you to be able to answer it if you see it on a standardized test. The corneal toricity, if you have essentially a spherical cornea, anything with less than 2 diopters of CIL, give or take, if there's no significant residual, then a GP sphere is appropriate. Whatever the corneal toricity is, whatever the delta K is essentially how much astigmatism the tear lens will create underneath that GP lens. If there's a significant amount of residual astigmatism, then it's simply stated that the amount of astigmatism made by the tear lens won't accurately correct that person's astigmatism. So you're going to need to add something on the front, a toricity, to make up for whatever missing astigmatism you have. And you can prism ballast it and you can put it where you want it to be, essentially, for our purposes. So let's look at the first one. You look at the 2Ks, it's flatter at the 180. Steeper at the 90. Here's my Rx, and theoretically these should have matched up. I should have made that 180. Sort of oversight, but 5 degrees difference is immaterial. The type of astigmatism, if you put it on a lens cross, -6. If it's a -6 here, and it's a -6 everywhere in the lens, and it's a -6 here because it's everywhere as a sphere, but 90 degrees away, there's also a -2, then that's simply going to equal -8. And if you take a look at the whole thing at 90, I have a -6 at 180. I have a -8 at 90. In this case, we gave it 175. So if you want to make it exactly correct, let's move that to 175, give or take. That's about 175. I have a -6 at 5. I have a -8 at 95. They're both myopic. So it would be compound myopic astigmatism. Pretty simple stuff. The orientation, if in -CIL, it's at 180 plus or minus 30. It's with the rule. So, and to determine whether it's, again, it's less than 2 diopters of corneal of toricity, delta K is less than 2. So we're going to use either a GP sphere if there's very little RA. If there's a lot of residual astigmatism, we're going to have to put something on the front to correct for it in addition to the tear lens. And in this case, it's 2 with the rule, 2 with the rule. This would be a GP sphere. So the answer to the first one is compound myopic with the rule, GP sphere. The next one, take a look at the type of astigmatism. In this case, it's still a -175 plus 125. I'm still having some people write this the wrong way. So let's get this in. It is a -175 at 90. So it's a -175. And it's a 175 everywhere on the lens. It's a -175 sphere. That's what the sphere is. But the axis corresponds, the sphere corresponds with the axis. So we only get the sphere here. 90 degrees away, we're going to get the full sill, which in this case was a plus 125. So if you look at that and do it all out algebraically, minus 50. So the total power at 180 is minus a half. The total power at 90 is minus 175. They're both myopic. So this again is compound myopic astigmatism. Please don't be fooled, because one is plus, one is minus. The easier way, if you don't want to map it out on a lens cross every single time, transpose it. If you transpose it, if in plus sill and minus sill, they're both compound myopic. If you transpose it and in both meridians, plus sill and minus sill, they're both plus, then it's compound hyperopic, and so forth and so on. If it's plus in one, minus in the other, if you have it in plus sill or minus sill format, then it would be mixed astigmatism. So you get the idea. Now, type of astigmatism, compound myopic. Orientation, careful, because it says 90, so you would imagine that it's against the rule, but it's not. We have to transpose it into minus sill first. And when we transpose this into minus sill, it'd be add them algebraically, minus a half. Switch the sill, minus 125, and change the axis, 180. So this minus 125, axis 180, makes this again with the rule. The difference, though, is take a look at the delta K. This one is essentially a perfectly sphere. It's within a quarter of being a perfect sphere. This lens with a GP sphere will create virtually no toricity, no tear lens that has any amount of astigmatism, but the prescription has a fair amount of astigmatism. So if we're going to do it, you can do a soft toric if you want. Or in this case, we're going to have to, if we're going to do a GP, what type of GP would be most suited? It would be a front surface toric, as in the answer key. In this case, 42.5, 44, it is flatter at 180, steeper at 90, minus sill, axis 180. This is a with the rule again, but the difference is it's a plus 1 at 180, 90 degrees, it's a minus a half. I have a plus 1 meridian, a minus in the other. This would be a mixed astigmatism. But in this case, because they match up, there's not a lot of corneal sill. And there is no residual astigmatism. It's 1.5 with the rule, 1.5 with the rule. If you compare the Ks to the Rx and they match up, in this case, it would be a GP sphere for number C, for letter C. And then in this case, I have a 3, 43, and 46. And this is a minus 2, minus 425, axis 180 type of astigmatism. I'm not going to beat you to death with it, but compound myopic with the rule. But in this case, if delta K is 3 and the Rx sill is minus 4.25, that minus 4.25 is essentially 33% or so higher than that 3 sill. So I was looking for back surface toric for this to work out properly. And the next one, again, this one is the only compound hyperopic, plus 8 on one meridian, plus 1125 in the other. It is transposed into minus sill with the rule, so compound hyperopic with the rule. And in this case, the Rx sill is not 3 times higher, so we're just going to go with our standard bitoric answer for this one. There's 3.5 diopters of corneal sill, 3.25 for the Rx sill. This would just be very simply a bitoric. And again, if this is over 3, give me bitoric every time, and you'll at least get partial credit, and you'll pretty much be correct. What parameters could you change to increase the sagittal height? Well, if you kept the base curve radius or the curvature of the lens the same, when you increase the overall diameter or the OZ width, you'll have a steeper sagittal height, an increased sagittal height, steeper curve. If we decrease the radius of curvature, remember there's an inverse relationship. as the CPC goes up, as this measurement in diopters goes up, the measurement in millimeters, the radius gets shorter. Remember, a shorter radius is a steeper curve. So it would be A, it would be D, and simply going from a 42 to a 44 in diopters for the CPC also makes it steeper. So ADE for here. Please, if you're still having trouble with this, I can't tell you enough. We've gone over it so many times that I desperately need you either just memorize it, make a chart, but this is absolutely important. You have a GP lens with the following parameters. Here's my base curve, but notice how it's in millimeters. I could ask for that in diopters, which we will. I've given you the optic zone width, and this one is a tricurve lens because it's got the primary, secondary, and peripheral, or primary intermediate here. So if we put it on a circle, remember, you'd essentially be looking at, we'll reformat this. So you'd be looking at a 7.2 millimeter overall diameter. You'd be looking at peripheral curves that were slightly bigger. Let's see if we center that. And the last one will be a little bigger. So if you actually did all this, this is what our lens would look like, give or take. And so the inside would be 7.2. Our second curve, or our intermediate curve, would be about 0.4 on this side, 0.4 on this side. And the peripheral curve would be 0.4 over here and 0.4 over here. So it would be 7.2 plus 0.8 on this side, 0.4 and 0.4. And then 0.8 here, 0.4 and 0.4. So 1.6 and 7.2 should be, if I'm not mistaken, 8.8 in terms of this right here, the overall diameter. Remember, the overall diameter is just this width plus all of your peripheral curves added together. 0.4, 0.4, 7.2, 0.4, 0.4. Add them all up with a calculator. Do it in your head. Don't care. But the answer is 8.8. CPC, all we're going to do is you can use the old-fashioned full formula. And the formula was the dioptric value equals n minus 1 divided by the radius in meters, or, and then that's in meters, so you have to multiply it by 1,000 to get millimeters, or you simply use our 337, and this would you'd be using n equals 1.3375, or just use our little formula where it says 3375 divided by this radius, 7.94, and it'll give us the answer, and I believe it's 42.5. Now, assume that you found, this is a cool one, you'll find this on the NCLE, assume you found that the lens on this patient did not give adequate vision because we've got to do an overrefract. Despite the fact it has the doctor's prescription, despite the fact that we're flawless in our execution, sometimes you put a lens on that you think is going to work and you still have to add plus a half, add minus a half to make it see better. But not only do they not see well, but you have to, it's fitting too steep. So you'd like to flatten the fit that's there because not only do they not see well, but they don't fit well. And you have to do them in 2 separate steps. So in this case, we performed an overfraction and we found that by adding a plus 75 to the prescription, they saw better. So that would be the first thing I would do. Take whatever I gave them, and here's the lens right here. It was a 375. And despite the fact that it fits terribly, in order to make them see better, in overrefraction, we'd have to add plus 75. So this would give us, if we did it in order, we went from a first adjustment would be, we would go from a 7.94 and we did it in a 4250 is what we said, which is a 42.50 diopter curvature lens. This is how steep the back surface is. and we originally had a -3. But we added a +75 to it. So this would mean that the lens was now the same curvature. We haven't changed it yet, but it's a -225. So in the next one, second adjustment, we said, well, we have to flatten the fit. So how do we flatten the fit by a half a diopter? We're going to make this a 42.00. That makes it flatter. But now we have to SAM-FAP, and it was a -225, but we have to adjust the SAM-FAP by steeper add minus, flatter add plus. Equals 775. So here we made two adjustments. One, we made the first prescription to make them see better, and now they see better but didn't fit well. So now we're going to change the fit, but every time we change the base, the CPC, the back surface, we're going to make a change in the lens power, the tear lens, as it were. And since we made it flatter, the flatter would have added a little bit more minus. So you don't need as much minus in the prescription that we had. So you just add 50, half a diopter. So the final is the base curve in diopters was 43.00, and the power is -175, and that's what you're going to order. So this would satisfy, if we put this lens on this person, and we found that we needed to over-refract, and we wanted to flatten the lens by a bit, if we put this here, it would have encompassed both the over-refraction, the change in curvature, plus the adjustment to the tear lens, and this person should have a lens that fits well, and it's one that they see well out of as well. And here, if you notice, I gave you all the steps. First, change the power of the existing lens using over-refraction, which we did. Then adjust the base curve, but then change it again using SAM-FAP. So the overall diameter, and this one I sort of messed up a little bit because I asked for, if you see, I asked for overall diameter. If you were very careful, you knew what I was looking for. This would have been 8.8 again, but I didn't want the overall diameter. What I wanted here was the radius of curvature or the CPC, and that would have been it was 42 for the CPC, because that's the lens that fits well. But if we converted back to millimeters, it would have been at 337.5 divided by 42 should be 8.03. And that's what I was looking for. So if you gave me that and you knew it, you got credit. If you gave me the overall diameter, because that's what I asked for mistakenly, you would have gotten it. And in this case, the -175. So again, I can give you countless more exercises for this. Maybe I'll add some of those to our next homework just to give you more practice to make sure you understand the concept. And that's the answer. Number 4, all multi-purpose contact lens solutions are now considered no rub to increase patient compliance. Well, it would make them compliant because nobody does it, but that is not true. They took that away. It was not as effective. And so we don't generally use a no rub solution any longer. If you read the directions, it does ask you to make a effort to rub the front and back surface of the lens to free up any deposits, even if you're using a multi-purpose, and then soak it overnight. Which disinfection system can you use with both soft and GP? Generally my multi-purpose for soft. Generally my solutions for GPs are for GPs, but we can always use a hydrogen peroxide based solution for either. And those are good for hybrids. They're good for sclerals. They're good for disinfecting sclerals, GPs, soft, what have you. And as a matter of fact, I tend to like those more than multi-purpose for some of my soft patients. Again, a contact lens is sterile after it's been properly cleaned and stored. With multi-purpose, the answer is no, 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 no. That is not sterile. It has been disinfected, but disinfected is just reducing the bacterial, viral, or opportunistic pathogen load just enough so you're less likely to contract a sickness, a disease. It gets it down so your body can fight it off, but it still has bad buggies on it. Sterile means there's nothing on there. And the only way we generally sterilize things is through an autoclave, high pressure, high heat, high temperature. We don't sterilize our contacts every time. We only disinfect them. So this would be false. We disinfect them, we don't sterilize them. How can a person who has a history of solution sensitivity, multipurpose, prevent their complications, discomfort? And disinfect the lens. You can't use non-preserved, here it says use non-preserved saline to disinfect their lenses overnight. You can introduce non-preserved saline for somebody who's sensitive, but that's not a system that will disinfect your lenses. It has no preservatives. People who have sensitivities will be less sensitive to them, but it won't disinfect your lenses. Just putting them in regular saline does not disinfect. It doesn't reduce the bacterial load like heat will, like peroxide will, like preservatives will, or like a UV cleaner may. So A is absolutely not a good one. You can use peroxide-based system because there's no preservatives, and generally after it's been neutralized entirely, your H2O2 is now essentially saline. There's no bad buggies and there's no bad preservative in there. And never the thimerosal. Thimerosal is a bad, I mean, that's just a gimme. So the only one who has a solution of sensitivity, the only answer here, 7, is B. Using the fitting guide, this is straightforward for a GP. What you want to do here, use the following guide. Here's my fit guide. Here is my prescription. Here are my Ks. So what did I do? Put it in minus sil. That would be minus 8.5, minus 75, axis 180. Vertex it, use your chart. So now we're going to transpose it. It vertexes from an 8.5 now that it's been transposed. So this transposes to minus 8.5, minus 75, axis 180. So we're going to use the sphere power 8.5. When we vertex it, this vertex is just the sphere. According to our chart, to a minus 775. If you wanted to do the math and you were off by an eighth either way, I'm okay with that. I would accept that. But essentially, we want to use this prescription, and that's what we're trying to get on the back of the eye. So this is my goal right here. So now we look, the RX, how much sil? It looks like it's 75. So we're going to fit this a quarter flatter than K. What's the flattest K value? 4750. The back vertex power then is going to be 1/4 flatter. So it's 4725 diopters. And then the CPC, I'm sorry, that was the 47.25 diopters is the back curve. I apologize. That's my CPC. But now we vertex it, we put it a minus. We vertex it, so it should be a minus 775, but we went a quarter flatter. Flatter add plus. So it's going to be a 750. And that's my answer. The answer is the back vertex power I would order for this person to see well is a 750 with a CPC of 4725. Now I could just as easily ask you to convert this to millimeters. I didn't. But if you wanted to put it into millimeters, you would simply take your calculator and 337.5 divided by 47.25, and that would give me 7.14 or 7.14 millimeters. So either one of these works. So if I ask for it in diopters, give it to me in diopters. If I ask it for millimeters, you have to convert it for me. And it may be an extra step, but if you know what you're doing, this should be it. 5 layers of the cornea from most anterior to posterior, epi, Bowman's, stroma, Decimase, endo. If you don't know that by now, I'm literally going to lose my mind. What are the 3 layers of the tear film? From front to back, lipid, aqueous, mucin, where they produced the meibomian glands, lacrimal accessory glands for the aqueous, and the goblet cells of the conjunctiva, specifically, generally the superior palpebral conjunctiva, not the bulbar so much. But so these are my three, and I wanted all those. Next one, given this refraction, -2 minus 1x is 170 rather. I used this lens. The following diagnostic toric lens was used. Ignore this. I don't care about this. I'm going to cross this off. All I know is during diagnostic evaluation, the lens rotated 20 degrees clockwise. Which way is clockwise? A clock goes 6 to 7 to 8. The bottom is swinging up and to the left. It goes with, clockwise is to the left. We're going to use our LARS. LARS. Left add, right subtract. We went left by 20. So we're going to add 20 to the spectacle RX axis. So what is the axis for 170? If we added 20, 170, and adding 10 is 180. If we continue to go, it would be 190, but there is no 190. It circles back around, and the answer would be 10. 20 degrees in contact lenses past 170 brings you to 180. 170 plus 10 is 180, plus another 10 gives you 10. So, because there is no 190. So the answer is B, 10, which the normal cornea is transparent during the pumping action, creating proper fluid balance. This is deturgescence. It keeps, if it gets too much liquid in it, it becomes irregularly aligned, and then you get cloudy corneal edema. And remember, we can check that with sclerotic scatter. We can check that with a couple other episodes. But where are the pumps located? The pumps are located in the endothelium, or A for endo. High plus lens may not fit well. That high minus, the lid will close over it, and then it'll pick up on that ledge. So we essentially do what's the equivalent of a roll and polish. Give me one moment. Very good. Let me share again. We're essentially shaving off the front of the lens of the edge thickness so that it fits better with the lid interaction. So what lens modification to the edge of the GP may help it? Minus lenticular, myoflange, anything along that line should suffice. HVID, what does that stand for? Horizontal visible iris diameter. How wide's the cornea? That's how we do soft lenses. We can do a lot of other types of lenses as well. And then the last one is pretty straightforward, I thought. Take your -8 in one meridian, -11 in the other. Again, there was this here to walk you through. If you just plugged it all in and did step by step, put your keratometry, your spectacle RX, put your flat K, steep K, sphere power, vertex and vertex. So now you're going to take your flattest K, and so you know what your flattest K is and your vertex sphere, your steeper K and your vertex sphere and sill power at 90 degrees away. So now just do your fit factor. Your fit factor is simply this right here. How much corneal sill do you have? 43 to 46.5 is 3.5 diopters. So we're going to fit the flatter K, 0.25 flatter, the steeper K, 0.75 flatter. So that just means that if we're doing the radius of curvature, we're going to do a quarter flatter than 43, which is 42.75, 3/4 flatter than the steeper, which is 46.50, and that will give me 45.75. Use your 3375 to convert those into millimeters, and that should have been 7.89, and that should be 7.38. So these were the answers I was looking for. And the back vertex power is simply my -8 that I vertexed, and that vertex is to a 725. So I would normally want the 725 here, because we vertexed it, and I would normally want the 11, which vertexed to a 975 here. But we fit this a quarter flatter, and this one 3/4 flatter, so I have to adjust it with SAM-FAP. After SAM-FAP. it would be a -7 and that 11, which vertexed down to a 975 if you just used you could do your formula if you want to do extra work, but you're always okay to use the vertex chart in my class for this purpose. And we did 3/4, so this would be after the steeper add minus, flatter add plus, we went flatter by 3/4. So the answer is -9. So what I was looking for this one is a lens that would give me a 7 here and a 9 here, a 789, 737, or we just do the diopters. A 4375 would fit very well along here. It'd be a quarter flatter. A 4575 would fit very well along the up or down. And it would fit remarkably well. And since we vertexed this and adjusted for SAMFAP, it's a -7 and a -9. So that's the first homework, just so to re-up that for you, just to give you some review, just to make sure if you haven't received all the grades, because I'm having reprocessing them and I'm trying to categorize each question to see how good it was, because if everybody gets a question, then it's not a good question. I have to get some that there are at least a handful that get it wrong. And so because of this, I'm trying to fix and analyze them, so I haven't gotten the entirety of every single person and every single analysis, but this should allow you to go through your paper, through your homework, compare what you got to what the answers are, and do a self-assessment and give you feedback on how to do it properly. So go through this whole thing, look at the answers, the video's here to help you out, and if there are certain things that everybody's getting trouble with, or a large percentage, we can put more of those on our homeworks and give more examples so we can keep doing them until everybody gets them right. So that's it. Thank you guys. I appreciate it, and I will see you soon.